Welcome back, ladies and gents. In this teaching video, I'm looking at 7.3 friction and static particles. 7.3 represents chapter 7, section 3 of the Pearson A level Maths Applied Maths Year 2 textbook. I'm going to start this teaching video by going through some important facts. I'll be looking at exam style questions where you have a particle on a rough surface. So, if a particle is on a rough surface, there is friction. Let's have a look at three major scenarios, three important scenarios that you need to know for the exam. Scenario number one, the particle is in equilibrium. This implies that the friction is less than or equal to the maximum friction F max, which is given by mu r. Mu is the coefficient of friction, r is the normal reaction. Scenario number two, the particle is in a limiting equilibrium. This means that the particle is about to move. So this implies that the friction has now reached its maximum F max, which is given by mu r. Scenario number three, and the final scenario, is that the particle is accelerating. This implies that the friction has now reached its maximum, which is F max. This is given by mu r. So you need to know these three major scenarios for the exam. Here is exam style question 1. A particle P of mass 5 kg is held at rest in equilibrium on a rough inclined plane by a horizontal force of magnitude 10 newtons. The plane is inclined to the horizontal at angle alpha, where tan alpha is equal to 3/4. The coefficient of friction between P and the plane is mu. Given that P is on the point of sliding down the plane, find the value of mu. I'm going to start by labeling all the forces acting on the particle P. So here is my particle P. Firstly, we have the weight acting vertically downwards. This is given by 5g, where g is the acceleration due to gravity. It is equal to 9.8 meters per second per second. So for this weight, we have component forces. We can construct a right angle triangle. This component over here is perpendicular to the plane, and this component over here is parallel to the plane. So we have a right angle, and it can be shown that this is alpha. We can put in the arrows. This is the adjacent, so this would be 5g cos alpha. This is the opposite, so this would be 5g sin alpha. Okay, now, because the particle P is in contact with the rough plane, there will be a normal reaction coming out of the particle P. So this normal reaction, we can label it as R. It is perpendicular to the rough plane. For this 10 Newton force, we have component forces. We can drop a perpendicular to the plane and form a right angle triangle. So we can put in the arrows. Alternate angles are equal, so since this is alpha, this must be alpha. This is the adjacent, so this would be 10 cos alpha. This is the opposite, so this would be 10 sin alpha. Now, it says in the question, given that P is on the point of sliding down the plane. So, given that P is on the point of sliding down the plane, friction needs to act in the opposite direction. So friction will be acting up the plane. So we can put in that arrow. What does it mean by this particular statement, given that P is on the point of sliding down the plane? Well, this means that P is in limiting equilibrium. So if the particle is in limiting equilibrium, friction has now reached its maximum. So we can label the friction as mu r. So we have mu r. That is the complete force diagram. Now I'm going to work out mu. First of all, I can resolve parallel or perpendicular to the plane. If I resolve parallel to the plane, I'm going to have two unknowns, and those two unknowns are mu and r. So to work out mu, I'm going to have to first work out r. So I need to resolve perpendicular to the plane. Okay, so if I resolve perpendicular to the plane, taking upwards to be the positive direction, we know that the resultant force F perpendicular to the plane is equal to 0 because the particle P is in equilibrium. So that resultant force would be R minus 10 sin alpha minus 5g cos alpha is equal to 0. Okay, so R is equal to 10 sin alpha plus 5g cos alpha. We are given that tan alpha is equal to 3/4. So I can use that particular statement to work out the exact value of sin alpha and cos alpha. So we construct a right angle triangle. Okay, so tan alpha is equal to 3/4, opposite over adjacent. So the opposite is 3 and the adjacent is 4. By Pythagoras' theorem, the hypotenuse has to be 5. So sin alpha is given by opposite over hypotenuse. So that will be 3 over 5. And cos alpha is given by adjacent over hypotenuse. So that will be 4 over 5. These are the exact values of sine alpha and cos alpha. We also know that G is given by 9.8. So we can substitute G, we can substitute the value of sine alpha and cos alpha into here to work out the normal reaction R. So R is given by 10 multiplied by 3 over 5 plus 5 multiplied by 9.8 multiplied by 4 over 5. So if I put this into my calculator, I get R equal 45.2 newtons in exact form. So that is my normal reaction. Now to work out mu, I'm going to be resolving parallel to the plane. And I can take, for example, downwards to be the positive direction. Now we know that the resultant force parallel to the plane has to equal 0 because the particle P is in limiting equilibrium. So we have 5g sine alpha minus 10 cos alpha minus mu r is equal to 0. So I can rearrange and make mu the subject. So if I do this, I get mu equal 5g sine alpha minus 10 cos alpha all over the normal reaction R. Okay, so I know that G is equal to 9.8. I've also got the exact value of R, and I know the exact value of sine alpha and cos alpha. I can substitute everything in to work out the value of mu. So we've got mu equal 5 multiplied by 9.8. Sine alpha is 3 over 5 minus 10 multiplied by cos alpha, which is 4 over 5, all over the normal reaction R, which is 45.2. Okay, so we can put this into our calculator, and if we do this, we get mu equal 0.473 to 3 significant figures. So that there, ladies and gents, completes exam style question 1. Here is exam style question 2. A parcel of weight 10 newtons lies on a rough plane inclined at an angle of 30 degrees to the horizontal. A horizontal force of magnitude P newtons acts on the parcel. The parcel is in equilibrium and on the point of sliding up the plane. The normal reaction of the plane on the parcel is 18 newtons. The coefficient of friction is mu. Find part A, the value of P, part B, the value of mu. So we're going to do part A and B first, then we're going to move on to part C. I'm going to start by labeling all the forces acting on this parcel. We have the weight acting vertically downwards. That weight is 10 newtons. For this weight, we have component forces. We can construct a right angle triangle. So this component over here is perpendicular to the plane. This component over here is parallel to the plane. Right angle, 30 degrees. So we can put in the arrows. This is the adjacent, so this would be 10 cos 30 degrees. This is the opposite, so this would be 10 sine 30 degrees. Now, since this parcel is in contact with this particular plane, there will be a normal reaction coming out of the particle. And that normal reaction is perpendicular to the plane. It's given in the question, it is 18 newtons. Over here, we have alternate angles. We know that alternate angles are equal. Since this is 30, this would be 30. Right, for this force P newtons, we have component forces. We can drop a perpendicular to the plane, form a right angle triangle, put in the arrows. This is the adjacent, so this would be P cos 30 degrees. This is the opposite, so this would be P sine 30 degrees. Okay, in the question we are told that the parcel is in equilibrium and on the point of sliding up the plane. So friction has to act down the plane. So we can put the arrow for friction acting down the plane. Now, if we are told that the parcel is on the point of sliding up the plane, this is just another way of saying that the parcel is in a limiting equilibrium. Now, when something's in limiting equilibrium, the maximum friction is achieved. It is mu r. So we can label the friction as mu r. We are given r, which is the normal reaction 18, hence the friction, you can label it as 18 mu. So that there, ladies and gents, is the complete force diagram. Now I can complete part A of the question, and that is to work out the value of P. So if we go to the diagram, we've got two options. we can resolve parallel to the plane or perpendicular to the plane. So if we resolve parallel to the plane, we will have two unknowns, and those two unknowns would be p and mu. Okay, so we won't be resolving parallel to the plane, we'll be resolving perpendicular to the plane. Because if we resolve perpendicular to the plane, we only have one unknown, and that is the p. So we can then rearrange and work out p. So I'm going to resolve perpendicular to the plane, taking upwards to be the positive direction. We know that the resultant force F is equal to 0 because the parcel is in equilibrium. So what is that resultant force F? Well, it will just be R, which is 18, minus P sine 30, minus 10 cos 30. So we have 18 minus P sine 30 minus 10 cos 30. So that resultant force F has to equal 0. So now I can rearrange and work out P. So if I rearrange, I get P equal 18 minus 10 cos 30 all over sine 30. So if I put this into my calculator, in exact form, I get 36 minus 10 root 3 newtons. And if we round this off to three significant figures, we get P equal 18.7 newtons. So that there, ladies and gents, completes part A. Let's have a look at part B. So in part B, we want to work out the value of mu. So mu is in the parallel direction to the plane. So we're going to resolve parallel to the plane. We can take, for example, downwards to be the positive direction. The resultant force F is equal to 0 because the parcel is in equilibrium. Okay, so what is that resultant force F parallel to the plane if we take downwards to be the positive direction? Well, it will just be 18 mu minus P cos 30 plus 10 sine 30 is equal to 0. Okay, so now we can rearrange to work out the value of mu. So if we rearrange, we get mu is equal P cos 30 minus 10 sine 30 all over 18. So if I put in the exact value of P into here, I get mu equal 36 minus 10 root 3 multiplied by cos 30 minus 10 sine 30 all over 18, the normal reaction. So putting this into my calculator gives me mu equal minus 10 plus 9 root 3 all over 9 in exact form. So now if we round off to three significant figures, we get mu equal 0.621. And that there, ladies and gents, completes part B of the question. Okay, moving on to part C. The horizontal force is removed. As you can see, I've removed the horizontal force. Part C, determine whether or not the parcel moves. Right, firstly, from the previous part of the question, I was able to calculate mu. This was the exact value. Minus 10 plus 9 root 3 over 9. The coefficient of friction mu always remains constant. Okay, so that is an important fact. Now I'm going to be labeling all the forces acting on this particular parcel. So we have the weight acting vertically downwards, and that weight is 10 newtons. We can construct a right angle triangle to find the component forces. This one over here is the adjacent, so it will be 10 cos 30 degrees. This one is the opposite, so it will be 10 sine 30 degrees. Because the parcel is in contact with the plane, there will be a normal reaction coming out of the parcel, but this normal reaction is no longer 18 newtons. I can call it R. Previously, you had a horizontal force acting on the parcel, and for that reason, the normal reaction was affected and it was 18 newtons. If you take off that horizontal force, the normal reaction now changes. We don't know what that normal reaction is, so you call it R. Now, this parcel will move down the plane if this component of the weight is actually bigger than the maximum friction. So what we're going to do first of all is calculate the maximum friction. So the maximum friction, F max, is given by mu R. Okay, so F max is equal minus 10 plus 9 root 3 all over 9. multiplied by r. So now I'm going to calculate r, the normal reaction. I need to resolve perpendicular to the plane. So I can take upwards to be the positive direction. The resultant force F has to equal 0 because the parcel is in equilibrium. So what is that resultant force F? Well, it will just be r minus 10 cos 30. And this must equal 0. Hence r is equal 10 cos 30. So I can put this into my Fmax formula. So Fmax is equal to minus 10 plus 9 root 3 all over 9 multiplied by 10 cos 30. So if we put this into our calculator, we get 5.38 newtons to 3 significant figures. So this component of the weight, what is that equal to? Well, 10 sine 30, if you put this into your calculator, is exactly 5. So we have 5 newtons acting down the plane. We're going to compare this with the maximum friction. What we notice is that the 5 newtons is smaller than 5.38 newtons, which is equal to Fmax. And for this reason, the parcel will remain at rest. So this implies that the parcel remains at rest. And that there, ladies and gents, completes exam style question 2. Here is exam style question 3. A particle P of weight 40 newtons lies at rest in equilibrium on a fixed rough horizontal surface. A force of magnitude 20 newtons is applied to P. The coefficient of friction is mu. Show that mu is greater than or equal to cos theta all over 2 plus sine theta. I'm going to start by labeling all the forces acting on the particle P. Firstly, we have the weight acting vertically downwards, and that weight is 40 newtons. Then we have the normal reaction coming out of the particle P. Remember, the particle P is in contact with the horizontal surface, hence there's a normal reaction coming out of the particle P. The 20 newtons has component forces. We can find the component forces by forming a right angle triangle. So we drop a perpendicular to the horizontal surface, we put in the arrows. This is your adjacent, so that will be 20 cos theta. This is your opposite, so that will be 20 sine theta. Because the particle is being pushed in this direction, friction has to act in the opposite direction. So I can label that friction in the opposite direction and I can call it Fr. So that is the complete force diagram. Okay, so we know that the particle P is in equilibrium. This implies that the friction Fr has to be less than or equal to the maximum friction, which is given by mu r. Okay, so this implies that Fr is less than or equal to mu r. So ladies and gents, our target now is to work out Fr and r. Then we can put it back into this inequality, rearrange and get this particular result. Let's start off by working out Fr. Now Fr acts in the horizontal direction. So we're going to resolve horizontally. And for example, we're going to take left to be the positive direction. So the resultant force F is equal 0 horizontally because the particle is in equilibrium. So what is that resultant force horizontally? Well, it will be Fr minus 20 cos theta. So Fr minus 20 cos theta is equal to 0. So Fr is equal to 20 cos theta. Now I'm going to work out the normal reaction by resolving vertically. So if I resolve vertically, taking upwards to be the positive direction, we know that the resultant force F is equal to 0 because the particle P is in equilibrium. So the resultant force vertically will be R minus 20 sine theta minus 40. So R minus 20 sine theta minus 40 equal 0. Now I can make R the subject. So if I do this, I get R equal 20 sine theta plus 40. So I've got my Fr, I've got my R, I can put that back into this particular inequality. So if I do that, I get 20 cos theta, which is Fr, is less than or equal to mu, multiplied by the R, which is this, 20 sine theta plus 40. Okay, so now I can rearrange. I get 20 cos theta divided by 20 sine theta plus 40, which is less than or equal to mu. We can write this inequality the other way around, and so if I do that again, mu is greater than or equal to 20 cos theta all over, I'll swap these two terms, I can write 40 plus 20 sine theta. Okay, so now if I compare this with this, I notice that in the numerator I've got cos theta, but over here I've got 20 cos theta. So what do I do to this fraction? Well, I divide top and bottom by 20 to give me cos theta in the numerator. So divide by 20 to the top and bottom. And if you do this, you get cos theta all over 2 plus sine theta as required. So that there, ladies and gents, completes exam style question 3 and this particular teaching video. If you found this video useful, please don't forget to subscribe, tap the like button, leave a comment and turn on the notification bell so that you get updates whenever I upload teaching videos.